Welcome to Aquatics Live YouTube channel.
Perfect.
Alright, welcome back guys to Aquatics Live. And we're getting back to the Magneto project here. And just kind of show you where I'm going with this now, because things have changed quite a bit, but I mean the goal for me has always been to get this set up so it's charging a battery and still running the bike. And then I had Kevin Todd kind of toss me an extra piece to it, which was trying to get this thing so it runs down at low RPMs, and I see the value in that. It's super important to me as well. So I've kind of changed up a plan and just trying to do stuff as low cost as possible doing this as well. So the situation got is that in order to trigger that spark, you have to have a waveform where it has a real high peak and then it has a dead zone in there. So you can't like put a capacitor in line with it. It'll causes it so it'll be a flat line all the time, and you're not going to get any no peak in there for the spark to read. So so to work around that, I guess I can hook this up real quick and just kind of show the peak situation, or we've all seen it already, but I'll just wire this in real quick. And I think you can see the screen up here, but if not, I will put a image in. So essentially, as you spin it around, you get the a waveform with some peaks in it. So that's how it works without at normal. And what I found is that the ignition module needs at about 50 volts in that peak for it to trigger. So that's a problem when you want to try to run at low RPMs. If you're trying to say we want to run at maybe 200 RPM or something, it only puts out maybe 8 volts at that time, nowhere near what it needs to be at, so it won't run, especially down low. No matter what you do, you can't get it to stay running at those low RPMs. There's a way around it, or that I thought of, is that my son had this little four-wheeler. It's like a little 110cc back when he was like 8-10 years old. That was okay for him, but now we're all too big and you really can't ride it. But the cool idea is I remember that thing really idles down low, and looking on Amazon, you can get the ignition modules for those for like $8 to $10. So they're pretty cheap. So that became my new goal, is how do we hook this, how do we make this work with one of those low-cost ignition modules. And I did find one. It was like $10, so is really cheap. But of course I had the one from his, so that's what I'm going to use for now. The only thing I needed to get was the pigtails for it. So I'll be showing you that stuff. But I'll kind of show you how I'm going to trigger, since I want to hook this up to the battery through my putting the diodes in there for rectifier. I can show you that. Kind of went through that before. You got the two diodes opposite facing on these. They have the lines on them, and that will charge things up and keep it so you have the peak in the fall. Those diodes will kind of protect the battery. And then as well, I'm going to put a Zener diode in there, which it's like 12.8 volts is the Zener that I have. It has a breakdown voltage, so it'll prevent this from overcharging the batteries. And I'll show you those real quick too. I'm going to be using these lithium batteries here. These are 32700s. So it's 4S. These are lithium iron phosphate ones instead of like 18650 ones. But anyway, this will be a nice little 12-volt battery. Making some tubes to put around this and then mount it to the bike, so I have a nice clean battery to go on there for this. And this has way more capacity than I'd ever need for lights and whatnot on the bike. So I know I'm kind of, but and that kind of feeds into where I'm going with this. So kind of set this to the side. So the next thing what I want to do is trigger on something else. And it made me think of, well, we already have a magnet spinning around, and there's a hole, an opening here, so we can mount something right in here to sense this magnet. And Hall effect sensors are the way to go on that. I mean, it's just the magnet is sending out their signals, so let's receive it. So I'm just going to kind of show how that works a little bit here. This is kind of the pinout of this I've put on here. And what I plan to do is, once I get done with all this, I'll make a little board that fits in here, and maybe I can sell those. I'm not sure how we're gonna do that yet, but I think if I had some interest in it, then essentially that would be a kit to convert one of these, convert the ignition on here from the standard one to the GY6 modules, DC modules. So I'm going to kind of show how the Hall effect works. Just kind of a science experiment time stuff. On this power supply here, I got it set to 12.5 volts, about like a battery. I just put the pin out of this. They all are pretty much the same. I do have a resistor between the out and the positive on here. The way these work is they output a negative signal, or I'm sorry, they output a negative signal, so you need to pull up the signal when it's not being output. Otherwise, you won't get any signal because it'll always be floating and you won't get anything out of it. Kind of a cool thing with these ones is they have a current limit in them, so they won't output more current than 25 milliamps out of here, which is perfect for all this. It's not going to burn anything out. No matter how it's hooked up, that output will never output more than the 25 milliamps. So, and the signal is going to kind of look like this. So you got the 12 volts coming across. It drops down to 0, and then it comes back up. Well, we're going to do it on the scope just for fun here. Oops, I got the wire snagged. Okay, so we are negative. It'll be the center wire here, the negative. Always hook up the negative first on this kind of stuff, because you don't want, these are sensitive. I really shouldn't be doing everything, out in the open. It should be in a circuit, but trying to be as safe as I can to not burn it out. These are nowadays electronics are a little bit more resistant than they used to be. So we're going to go with the positive over here. So we got our negative and our positive, and now this is our signal wire over here. So I'm going to get my scope hooked up. We'll hook the scope up to the negative here. Just backing it up on this plug, and then I'll hook the that's the ground wire for this, and then this is the signal wire for the scope. So I know it's kind of all janky, but there you go. And let's see here. So now on the scope, I really hope we can right now I'm at the scale of 5 volts, so my signal is already at 12 up here, so I'm going to try to raise it up so you can see it when it dips. And I got this set at 100 milliseconds, so it's going to when it triggers, it'll drop down. And okay, there we go. There's a little magnet on the stick here. I'm just gonna wave it in front of this, and we should see that signal dipping down. So I'll put it on the motor here, and if I go back through the video and you can't see it, I'll trigger the signal and put a picture in right here too. So all right, so we're gonna swing this around, and you can see it's triggering. So they're nice clean triggers, but the issue with that is that, like I was saying, it drops down to 0 and comes back up. And our ignition module is expecting the opposite of this spiking up and then coming down. So I have to work around that. So the next step in the process, or next step in the circuit, is to throw a transistor in there to invert that signal around. That's pretty, made a little sheet for it. You can see this is this is a 2N4403, and I'll just kind of show you how this works here. I'll trigger it via the wiring here. So let's pull this one off, because now we remember the signal coming to this will be essentially a ground signal coming to it. It triggers it. So I'm gonna hook this up now. Get these wires out of here. All right, so we need the battery plus. And let's make sure. Oh, on this resistor on here, I added that as it's a pull down in this case, because these require some kind of load. If you had load on it, that coil in the load would be your pull down resistor going to ground. And when you had power coming out of here, that would bring it down. So you had like a light bulb or something, could be used in this situation here. But I just put a resistor in here. I'm going to put ground here. Then we can pick up our signal in that spot right here where this connects together. So sorry if this is definitely not super high-end circuitry, but maybe over-explaining things, but figured it's best to give a little extra info. All right, just came out of the little paper here, but okay. So then we need our positive. This goes onto this wire over on the side. And now I'm gonna hook up our scope. And we're reading on the, oh boy, okay. I know it's pretty crazy, all this. So, okay, so we're gonna put our scope on over here. And I don't know how, hopefully you can see. I'm just gonna have to do it down here and hope it's on the camera. I'm gonna grab our ground off of this lead over here. So it's kind of I'll hold it up again. I need one more thing. So we're going to send a ground signal to that center pin, and that'll trigger the transistor. So here we go. We've got a ground wire going to the power supply. And let's get the scope, move it down. So now we're trying to see now we're trying to see the opposite. I didn't make one of these, but we're trying to see one that goes up. So that's what we're after now. So I just moved the bottom line. So we're at 0 down here, and we should see it spike up. And yet again, if it doesn't show up on camera here, I will take a picture of it later and add that to the video. There we go. It shows up in this. I think you can see it. Yep. And it's me banging it on there is not a clean signal, but that's how that works. All right. So now there's one more step now. Now we have a clean signal coming from here from our motor. Clean signal through our circuit to the coming out of there. And this is completely separate now. So we can use that for our charging, and our signal is going to come from a little board mounted over here. All right, now the ignition module. So this is the little ignition module. Some of them are just like black, and they're all filled in. I had gotten this one for his four-wheeler because the one that came in the four-wheeler originally, it lasted maybe a week after we got it, and then there was no more spark. So I did get one in aftermarket back then. So he's like 19 now, so that's quite a while ago. But I dug through my junk. I actually bought 2 of them. So, but anyway, we got extras, and so that's what I'm going to use for this. And they are pretty cheap. So we got this, and then there's the coil from the bike. The one that's this is the one that came with this kit or whatever, but the one that's on there right now is like a metal boot, but whatever, it doesn't matter. On here we have the green ones, the ground, and the black one's the positive, but it's just kind of like an ignition coil. These both go to this to the center here, and so they link through that. So it's a large coil going through there. Got the primary and secondary coils, essentially, is what got going on with these. So we'll look at that here in a minute, but first let's get this kind of set up. So we got our signal coming in now, and I went through these and kind of labeled them. And I wouldn't trust everything that you see online. That was something that bit me at first, was that this is a DC module. They had labeled one of these to be a switched battery source, and after I looked around, or after I used the good old multimeter, I checked resistance between the pins, and the trigger pin, which is this upper one here, and this top of this second skinnier pin or skinnier plug here are the same wire. So of course, so in order to, as a kill switch, if you send this one to ground, it's a kill switch. So you just like how the bike's already wired, you can just leave that one hooked up and swap it to this wire. So that's kind of good. These bottom 2 wires on here are ground. I just labeled them ground. And I put some spade connectors on the 2 wires that go to the coil. So we got one ground wire, and we got the positive wire going to the coil. So, all right, let's get this hooked up. Oh, there's one more piece to this, is that the trigger on on these is like a coil of wire that is ran next to the stator, and so this module thinks that there's supposed to be a coil of wire there, so essentially that's an inductor. So I'm just gonna use up a coil of wire that left over from the coil winding project as my inductor for this experiment. I will get I'm gonna get an inductor to put on the PCB when I make them. I'm gonna make a batch of them, so when I do get them done, I'm willing to give them out to people on my channel, and they can try them out and see what they think. So and then if they work out and people like them, then I can toss them up on eBay later. But my first batch of fans and get them for free anyway. So so let's get this hooked up here. So get all this wires untangled. All right. Ground. We'll hook up our coil here. Let's put our the green wire on here. I got a spark plug in here for us to test with. I don't know if you'll be able to see the spark on camera or not, but we'll try. To get our other lead on here. And label this one the red, that's the power. And we're running like 14 milliamps, so pretty low. And our ground, oh, we already got a ground. Oh yeah, we need that for the, here's our little thing. Yeah, like I just used the roll left over. There's a wire that goes to the center, and I just soldered some wires onto there, and there's the outer one. So this is what an inductor is essentially, but it's not in a fancy case or whatever that when you buy one. So, and then inductors are like 50 cents or 10 cents or whatever, I don't know, pretty cheap. So put a ground wire on it, and this will be our trigger wire over here, and we'll put that on here. Boy, oh boy, that's lots of wires. But okay, so we're going to connect these two together. Just going to grab a little clip on there. So we've got those two hooked up together. Boy, should just solder them together, but all right. Okay, they're together. So yeah, it's kind of kind of rinky-dink how I got all this hooked up together, but it's just a science experiment to show how this works. And now we got our positive here, so this would be our trigger from that transistor that we were showing earlier. So we'll get the signal. We'll get the signal from it, pops up, comes over, and that's going to be me hitting the end of this trigger here. But the good thing about this is no matter how slow the motor's going, you're going to get that trigger. I'm going to try to hold it up, and you can, it's kind of, see, I thought I had something dark here to, let's see. I don't know, maybe you might be able to see it if I hold that up there. But just trust me, it's sparking. And it'll spark the same no matter how slow it's going. And I don't even have this grounded. Yeah, I bet I can get a much cleaner spark if we hook up a ground wire to this. Let's do that just for fun. I bet we can maybe we can get it a little brighter so you can see it on the camera. and it won't shock me. Alright, let's try this again. See if we can get this to show up. Anyhow, it's working, just trust me. So no matter how slow it's running RPM wise, it'll be firing off a nice clean spark. So that's today's weird science experiment. We had a bunch of snow, and so waiting for it to melt off so I can go for another ride. I have a few more things. I did get a bracket for a cup holder, and I'm like using a coffee can to put up on the handlebar so I can put my drink up in there. And then I'm also gonna put a phone holder up on the handlebars, so I'll put an old phone in there so we can do like a speedometer like I've seen on other people's videos. So I'm kind of getting ready for and then maybe we'll go for a ride to the gas station or something. So kind of excited for that. So I'll see you guys hopefully another few days here. So thanks.